Hi everyone, and welcome to our video on more finding the derivatives using our basic rules. So we just did a video where we were using them. We're going to continue them. They're based on this box. So we have a power rule that's the most important, I would say, but we'll break these down. Okay, so in this, find the derivative first. And this is saying do the derivative of this function. Okay, so this is a slightly different notation than the ones that we had up here. Okay, so dy dx or y prime. Okay, so we saw different ones. This time it's just saying, okay, so you're just about to do the derivative. So the way that we would write this, first thing we need to do is, well, we need to rewrite this part because we need x to a power like that. So x in a denominator we don't like. Okay, so change x in denominator by using, let's go up one more time, this rule. Okay, so we had a review session with these power rules. Okay, so just like number 4 that's circled, so we want to just move it up and then make the power the opposite. Okay, so the way that this gets written then, so we keep dx, so this is saying we're about to do a derivative, but we need to change that to be 2x to the negative 2 minus 3x to the negative 1. Okay, so the 2 and the 3 are constants. They're just hanging out. The x is what's getting moved around with the negative power. Okay, now it's ready for us to do the derivative. Okay, so the ddx, we're saying we're doing the derivative now. And so that means that 2 is just hanging out. And then we'll apply our power rule to the x to the negative 2. So I like to do this bracket and say, well, the negative 2 would go to the front of that x, and then minus 1 from the power. Again, be careful. I'm just going to put a little minus 1 there. Negative 2 minus 1 would be negative 3. And then we have minus 3. Oh, let me put my bracket there. Almost left it. Okay, and then we have minus 3. And then now we're doing our derivative to this x to the negative 1. And it might help to just put the full bracket right away. So it's saying, okay, the negative 1 would come to the front, and then minus 1 from the power. So negative 1 minus 1 would be negative 2. And then that's our step of calculus, and then we just need to clean it up. So 2 times negative 2 would be negative 4. So that multiplies like normal. And then x to the negative 3 is left over. And then notice here we have a minus 3 and a negative 1. That would become plus 3 when they multiply. And then x to the negative 2. Okay, and then this might be fine if they don't care about the negative power, which often they do not. But if they want us to rewrite it, then this would be negative 4 over x cubed. So now we're using the rule in reverse. The negative power we can move down and make a positive power. And then plus 3 over x squared. Okay, so these are the same thing. Just it depends on which one they might prefer. Again, the first one's probably fine, but sometimes they don't like negative powers. Okay, number 2, this is still also find the derivative. Again, notice this notation. I don't have like y prime involved. I mean, we could write it, but this is more just showing equals equals equals. Okay, so first, in the black ink, this is not ready for us to do the derivative. So I'm going to keep that there and saying, well, we're about to do it. We need to use our exponent rules to rewrite these. Okay, so the 5th root of x, so this one, would become x to the 1/5. And then we have plus 6. The square root of x down there would be x to the 1/2. Okay, and then now we need to use our power rule again. So we have the derivative. So we're about to do the derivative of x to the 1/5 plus 6. This x to the 1/2 down below needs to be x to the negative 1/2 up top. Okay, so now it's ready. So we always need x to a power just like these. Okay, so now that it's ready, in the blue, let's do our derivative. Okay, so now it's saying we're doing it. Do the derivative to those two terms. This first term, the 1/5 would come to the front of the x, and then minus 1 from 1/5. Okay, so if we need scratch work, that's fine. I'm just going to put it right here. 1/5 minus 1 would become really 1/5 minus 5/5, which is negative 4/5. Okay, so that's negative 4 over 5. And then we have plus, the 6 is just hanging out, and then these, or that x to the negative 1/2 will do our rule. Okay, so negative 1/2 to the front, and then x, and then again, minus 1, be careful. Okay, so this was just scratch work, so I am just going to scratch it out, actually. Let's do some more scratch work. So it's negative 1/2 minus 1. And even here, I'm just going to instantly make it 2 over 2. So that becomes negative 3/2. Okay, so that power is x to the negative 3/2. And again, this I'm saying is scratch work. That's why I'm scratching it out. I don't need it anymore. And I just don't want it be confused with the rest of the problem. I mean, we could erase it or block it off. Okay, but that is doing the derivative. So that in the blue, done. Now we just simplify again. Well, the first term looks fine. 1/5 x to the negative 4/5. Here we have a positive 6 times a negative 1/2. That would be minus 3. And then x to the negative 3/2. Okay, and then like before, these negative powers are usually fine. If they don't like it, we could change it. Let's do that one more time. So we would have 1 over 5, and then the x to the negative 4/5 would move down and become a positive 4/5. And then minus 3, x to the negative 3/2 would move down and become x to the positive 3/2. Okay, so that's another option. Again, this first one, I'm saying that's probably fine. One last time, they might say, oh, let's rewrite it to be radicals. So we're using, again, our rule in reverse. They're saying, oh, x is to the 4th power. The 5th in the denominator is the root. So it'd be the 5th root of x to the 4 minus 3 x cubed, and then the 2 is the square root, so like that. Okay, so that's an even final different looking answer. So you have all different ways to write it. Okay, and let me fix that 5 right there. Just a little bit, and then we'll say we're done. There. Okay, so 5, and then the 5th root of x to the 4. Okay, I think, again, the first one should be fine majority of the time. Okay, let's do this one. So we can evaluate it, and we'll break this down. So we've got let g of x equal x to the 3/2 and then over 6th. One thing that might help, so 6 is in a denominator, there is a 1 in front of that x. So we could rewrite it as 1/6 and then put the x to the side. So if that helps, do it. I'm going to do it for now, and then now we're ready to do the derivative. So we'll find this. So g prime of x, the 1/6 is hanging out, and then now our power rule to this part, 3/2 comes to the front, x, and then minus 1 from that, 3/2, again, scratch work. That would be 3/2 minus 2/2. If you can use a calculator, I mean, you can plug it in too, but it looks like that. Okay, so that was my scratch work. And then now I'm going to simplify. Okay, so so I'm done with the derivative. So my derivative, so I was doing in blue. And then we would simplify this. Well, again, 1/6 times 3/2 would be, you can multiply through the numerator. 1 times 3 is 3. 6 times 2 is 12. And then x to the 1/2. And then one more time, let's fix that 3/12. That would be 1/4 x to the 1/2. Okay, so again, if they don't care about the way that looks, then that's going to be it. Now let's do g prime of 4. Okay, so g prime of 4 is telling us put 4 into this x in that function. So that means it would be 1/4 and then 4 to the 1/2. Okay, so the left side is good. This is g prime of 4. And then now we just need to simplify this. Okay, so 1/4. Again, if you have a calculator, 4 to the 1/2 can be inputted. You might need to find that key and make sure to put the parentheses as needed. Or we can go back and say, hey, 4 to the 1/2 is the same thing as the square root of 4. So we can always rewrite it. Square root of 4 is 2. Okay, so that means we could just say, oh, that's just 2. And then 1/4 times 2, that would be 1/2. Okay, so what that means is So now we've got let's put a little wording on this one. So it's saying the slope of g of x at x equals 4 is 1/2. Okay, so the m tan is 1/2 there at x equals 4. Okay, so that's what that one means. We'll see another similar problem in another video coming up that I'm going to plug into a calculator. But for this one, I'm just going to end it right there. Okay, so that's it. Thanks for watching. If you have any questions, please let me know.